Today we are going to start a new chapter, a very interesting chapter, chapter 12, lesson 1. In this lesson, we are going now to learn how can we organize the data using the matrices. You have a data, you want to now organize it by matrices. So let's see now what is the matrix. Matrix is a rectangular arrangement of numbers. So how to represent matrix? You have to make them like this. This is meaning a matrix. It is a rectangular arrangement of numbers. Each numbers, they have a row and they have a column. So this is a matrix. I have like 2, 3, 1, -1, 0, 2, 0, 1, 4. This is a rectangular arrangement. We call it matrix. Now this one here, we called it row 1. This is here, row 2. And this is here, row 3. And this is for the rows. And also, this is column 1. This is column 2. And this is column 3. So each matrix, it has a number of rows and has a number of columns. Now, so I use it to represent or to organize my data in order to use them in many operations. Now, word of matrix is a singular matrix, and I mean here one matrix. If I want to say 2 or 3 matrix, I will to say now 3 matrices. This is the plural. So matrix is a singular and matrices is a plural. 1 matrix, 2 matrices. So what is the matrix? I will repeat. It is a rectangular arrangement of numbers. This rectangular arrangement, it has rows and columns. Let's have an example here. Here we have Jeff, Tina, and Eric run a landscaping business. They charge $12 per hour. How much should they bill the Ogwas? Explain how I found your answer. Now here we have a data. How each of Jeff, Tina, and Eric pay $12 for each activity or for each landscaping business. Look at here. For Jeff, on Saturday, he pay can say bill 5 hours for the Ogwas and 2 hours for the bakers. Tina on Sunday, she paid 2 hours for the bakers and 1 hour for the Ogwas. Smith, they told me like all of them from the family of Smith. Tina 3 hours, Jeff 4 hours, Eric 2 hours. This is on Sunday. So there we have an unorganized data. Then they told me that Jeff on Sunday, he pay 1 hour for Ogwas and 3 hours for bakers. And on Saturday for the Ogwas, Tina 2 hours and Eric 3 hours. And on Sunday, Eric he can pay 3 hours on Ogwas. So as you see here, we don't have an organized data. I want now to organize them in a matrix. What we have to do? The matrix now, let's start with the first one, which is the matrix shows the number of hours that Jeff, Tina, and Eric work on Saturday. So the first step here, I will draw my matrix here. Now, I want to see where they are on Saturday. So I have to use this paper here. This one, I don't want it. This one, it has Sunday, okay? I mean, I want on Saturday. So if the paper has an Sunday, don't look at it. Here we have Sunday, I don't want it. Here we have Saturday. So I have to use these two pieces of papers for the Saturday. I have to use the data on them. Then what you have to do then you have to say this is the first column for Jeff, the second column for Tina, and the third column for Eric. Sorry, row. The first row for Jeff, the second one for Tina, and the third one for Eric. And I have to use, since I have two landscapes, Orgwas and bakers, so the first one here for Orgwas and the second one here for bakers. After now I list my matrix, let's now put the numbers inside the matrix. Let's start now with Jeff. Jeff, on Saturday, he spent 5 hours on Ogwa. So Jeff, on the Ogwa, 5. So from here, this 5, it's mean for Jeff and for the Ogwas. And for the bakers, 2 hours. This is for Jeff. Here, this is my first. Let's put here like a number. I didn't put them later on, but just here to see what we have to do. Now look, go to Tina. They told me that for the Ogwas here, from this paper here, that on Saturday, for the Ogwas only, Tina spent 2 hours and Eric spent 3 hours. And I don't have any data for the bakers, so I will put them as 0. So from this matrix now, what can I see? I can see that Jeff spent 5 hours on Ogwas and 2 hours on bakers. Tina spent 2 hours on Ogwas and 0 hours on bakers. And Eric spent 3 hours on Ogwas and 0 hours on bakers. So from this table now, from the first one, you cannot answer the question easily, but from the matrix, if I asked you which from the 3 people here, Jeff, Tina, or Eric, spent the most hour on the Igwa or on the Igwas?
Jeff.
Jeff,
Yes.
exactly. That's it. So here from the matrix you can answer. Now let's ask you another question. Which one spent the more Igwas on Sunday? Don't look at the matrix now. Look at the piece of papers.
Eric.
Now, as you find that it's hard for you now to tell me which one is the greater. So to make it easier to answer my question, let's now first arrange a matrix. When I arrange it, I can answer this question. So let's now make a matrix for them on Sunday. I will repeat the steps. Here, this is for Jeff. This is for Tina. This is for Eric. This is for Ogwas. And this is for bakers. Then, yeah.
So what about Smith?
No, Smith, this is the family. Family name.
Okay.
Okay, now here, let's go now on Sunday. So I have to use this piece of paper. Sunday, this one is Sunday also. This one here is Sunday. And this one here is Sunday. Now, let's look here. The first one, the green one, they told me that Tina on Sunday, she spent 2 for the bakers and 1 for the Ogwas. And for Sunday here on the blue one, we have the Ogwas. Jeff, they spent 1 for the Ogwas and 3 for the bakers. And Eric, she spent 3 hours for the Ogwas on Sunday. And 3 hours on Sunday. And there's nothing here for the bakers, is it right?
Yes, teacher.
Yes, so I will write it as 0. Now, after that, when I organize now the matrix, now I'll ask you, which one, I mean, who has spent more hour on the Ogwas? Or the greatest number of hour on the Ogwas?
Eric.
Now,
Eric.
after I organize the matrix now, I can understand how everything is working. Is it clear?
Yes, teacher.
Yes, miss. Yes, miss.
Now,
This is a bit confusing.
now. As we did on the variables, when we have 3x squared, you want to add them to 5x squared. And you have 3x squared, you have to add them to 5x. Which one can be added? The first one or the second one?
The first one.
The first one. Exactly. Because I have the same number, the power here are the same for the two variables, so I can add them. But if they have different number of the powers, I cannot add. Here, approximately, we have the same for the matrix. Now, they told me that if we have this matrix here, 2, 1, 4, 3, 1, 0. And I told you now, tell me or identify the size of the matrix. I want you now to write the size of the matrix. To write the size, you have to write the number of the rows times the number of the columns. So to represent the size, you have to write the number of the rows times the number of columns. Be careful, not columns by rows, rows by columns. So what you have to do here, let's count. How many rows we have? 1, 2. So I will write down here 2 times. Let's count now how many columns? 1, 2, and 3. 3. So for this one here, what is the size of the matrix? 2 by 3. Is it clear?
Yes, miss.
Okay.
Yes, miss.
This is to identify the size. Let's take another example. If we have it as here. What is the size of this matrix? How many rows we have?
3.
And
How many columns?
4.
4. Exactly. So you will tell me that it's a 3 by 4. This is the first thing here. Now, each number on the matrix, like if you have, let's come back here. Now, each number in a matrix, we called it element. This is an element. This is an element. Each number here, we called it an element. If I told you now as an example, where is number 0? Oh, this is 1. Where is its position? You have to tell me it is in row 3, column 3. Number 1, it is in row 1, column 1. Number 4, it is in row 1, column 4. This is, I will not ask you later, but just here an extra information. So the first thing here, we know how to arrange the matrix, how to find the size, of the matrix, and we name each element or each number on the matrix, we call it an element. Now, as I told you, if you want to add two variables, they have the same number of power, and for the matrix, we must have to do the same. What did I mean? I mean, like, if you want to add them, I must have the same size. So only the matrices or only the matrix that have the same size can be added. If they don't have the same size, cannot be added. What did I mean? Like the first matrix, it must be 2 by 3, and the second matrix, it must be 2 by 3. If they have the same size, I can add them, and the final answer of the final matrix will be 2 by 3. So the first step here, if you want to add two matrices, they must have the same size. The second thing, that if you want to see, or to tell me that, sorry, that these two matrices are the same, such as here. Here we have 1, 0, 3, 2. This is 2 by 2. And here we have 1, 0, -1, 2. This is also 2 by 2. Now, when you want to tell me that if this matrix, or if these two matrices are the same, they have to be the same at the size. They have the same size, 2 by 2, 2 by 2, or 3 by 4, 3 by 4, and they must have the same number in its corresponding position. I mean, like the first number on the first row in the first column must have the same number. يعني 1, 1, 0, 0, 3, -1. This is not equal. So I will say that these two matrices are not equal. To say that these two matrices are equal, they have the same size of the matrix and they have the same corresponding size. If they are the same, I can say that these are equal. Let's have another example now. -1, 2, 4, and 0. Let's see now if it's equal with this matrix or no. Before that, let's simplify this one here. Now, 5 minus 1. I want to simplify this one. 5 minus 1.
4.
4. So let's write it now as 4. And 4 over 2.
2.
2. Exactly. After that, now, I want to check if these two matrices are equal or no. Are equal, they have to have two, or they have to have two things. If they are happen, I can say, or if they are accomplished, I can say that these are the same. The first is 1, they have the same size. What is the size of the first matrix?
2 rows. And 2 by 2.
2 by 2. And the second one?
2 by 2.
2 by 2. So, the first thing, check the size. The second thing, check the corresponding element.
Miss, I have a question.
Yes, Huda.
Why here you put 2, not 4 over 2?
I simplify them. 4 divided by 2 is 2. So let's see. So for the size, yes, they are the same. Now let's check the corresponding element. The first one, the first example, when I check the corresponding element, they are not the same. So I'll say that these two matrices are not the same. Here we have the same now. Let's do here. Check each corresponding element. This one with this one. Corresponding element, it means that they have the same position. يعني row 1, column 1. This one here, row 1, column 1. Then this check. 2 with 2. 4 with 4. 0 with 0. So each corresponding elements are the same. So I can say yes, these two matrices are the same or are equal. Is it clear?
Yes,
Yes.
Now, let's start with the first thing that we're gonna learn from them or from this lesson here. That's how to add and subtracting matrices. Now, sometimes you have to add or subtract the matrices in order to solve problems. They told me that you can add or subtract matrices that they have the same size. 2 by 2 plus 2 by 2. If they have the same size, they can add it. How? You can add or subtract two numbers by adding or subtracting the corresponding elements. Did you see the corresponding elements that I put them before? You have to add or subtract them. Let's see here. Here now we have the first matrix. -5, 7, 2.7, and -3. You want now to add it to -3, -3.9, -4, and 2. Now, to add them, you have to add each corresponding elements. What did I mean? Here we have -5. And before that, let's check if they have the same size or no. 2 by 2, 2 by 2, yes, they have the same size. So I can add them now. Now let's add -5 with its corresponding element, which is what? -3. So I have to add -5 plus -3. Then
After this is added, no problem if we add.
yes, here you have a plus. Here you have a plus between the two matrices. So you have to add each element. If you have minus, you have to subtract them. So now 2.7 plus -3.9. 2.7 plus -3.9. Then I finished the first row. Now let's go to the second row. 7 plus -4.
7 plus.
And then -3 plus 2. After I add each corresponding elements, let's now simplify this matrix. How? Let's add the first one here. -5 plus -3. -8. So
-8.
here we have -8. Then 2.7 minus 3.9.
Equal -1.2.
-1.2. 7 plus -4. It's 3.
3.
And -3 plus 2.
-1.
-1. So after I add them, each elements, I have now the matrix. Now look at the final matrix here. What is the size of the matrix here?
2 by 2.
2 by 2. That's what I did you before. If you want to add two matrices, here they have the same size, and the answer or the summation or the matrix that has the summation of them must have the same size. Is it clear?
Yes,
Yes.
thank you.
Let's have now another example here. Now for this one here, we have as 3 rows with 2 columns, 3 rows with 2 columns. They have the same size. I want now to subtract them. Why subtract? Look at the sign here. It has subtraction. So I want to subtract. What we have to do here now? Now, 2 minus -1. This is the first element. Then 11 minus 11 minus 8. Then after that, -4 minus -6.5. Then 3.2
plus -4.
-4. Yes. Then here, yalla. 1.5 minus 0. And the last one,
-5 minus -3.
-5 minus 3.
-3. Bravo. So now, as you see here, after I arrange it, now be careful. Since I have the elements are arranged like 2 or 3 rows times 2 columns, so when I arranged the final matrix, I have to do the same. And don't write the numbers like this. 2 minus -1, 11 minus 8, and -4 minus 6.5. This is false. Here, I have it as 2 columns times 3 rows. So I must fill the final matrix as it is. Don't put it as you want. Okay? Did you understand what I mean?
Okay.
Yes. Miss, can you just repeat because you didn't get it very well?
This one or the one that I said before?
No, the one that you raised now.
Okay. Right. Now let's have here an example. I mean, like, if you have it as an example here, another example, okay? If you have it like 2, 1, 4, 0, you want to add it to 1, 7, 3, 2. Now, if you want to add them, the correct matrix must be have. Look here, what did we have? We have 1, 2, 3, 4. So we must have the same number. Then we ought to add them. You have to say 2 by times 1 is a 3. 4 plus 7 is 11. 1 plus 3 is 4. And 0 plus 2 is 2. Now, don't say it is like this. Here we have, don't say مثلا as an example, 2 plus 1, 3, 1 plus 7, 8, 1 plus 3, 4, 0 plus 2, 2. This is false. I mean, like, if you want to arrange the two matrices, I've arranged them as the same, the origin.
Okay.
Okay, don't put the number, I mean, like, don't put the numbers as you want. They have to be arranged. Of which arrangement? The same as the first matrices. The first matrices, which they are added, the size of them must we have the same size when I add. So but that when you want to arrange the numbers, don't arrange them as you want. Arrange them in order.
Okay, miss.
Okay, now let's come back here. So 2. Yeah, now let's simplify to find, in order to find the final one. 2 minus negative 1 is mean 2 plus 1, which is a 3. 11 minus 8.
3.
3. Negative 4 minus negative 6.5. It's mean negative 4 plus 6.5.
6.5. Equal to 2.5.
2.5.
2.
3.2 minus 4.
1.2. Negative
1.8. Now, 1.5 minus 0. 1.5. Negative 5 plus 3.
Negative 2.
Negative 2. So this is now the matrix after I simplify it.
Teacher, I have a question.
Yes, Lesson1.
What do you make if there's 3 columns and 2 rows? Wait, teacher.
And do you mean if they have different size?
Yes.
Don't add them. Tell me it cannot add it. Or it cannot be added. Yeah. Do you have any question here? Or because I want to solve now, got it 1.
No, teacher.
No.
Okay. Now, get it 1. 5, 3.2, 4.9 plus negative 9, negative 1.7, and negative 11.1. I want now to add them. What we have to do here? Yeah, let's make it like this now. 5 plus negative 9. This is the first one. The second one, I will repeat. The arrangement here is 3 numbers under each other. So the final matrix must have the same shape, the same size. So 3.2 plus and 4.9 plus negative 11.1. So then here 5 plus negative 9, negative 4. 3.2 plus negative 1.7, it means that they are subtracted. 3.2 minus 1.7, this is 12, this is 2.
1.5.
So 1.5. And 4.9 plus negative 11.1. So that's mean I have to subtract them. And they must have minus sign. So this is 11, this is 10. So negative 6.2.
Teacher, you have to add. Because both of them are negative.
Yeah?
Teacher, the sum of 4.9 is negative. Negative 4.9, negative 11.1. So we'll add. Correct?
It's 4.9. Ah, okay. I'm sorry. I forget the minus sign. They are negative. Okay, I'm sorry. I have it as positive 4.9. So 15, 16. So it is 16. So this is here the final matrix. Negative 4, 1.5, and 16.
Miss, negative 16 or positive?
Oh, negative.
Because the...
One second. Now here after 3 minutes the period will, or the first period I mean, will be finished. So I want you now to solve B, okay, or oh no, sorry, let's solve it now. This is for B, and later on I will give you another example. 3, 7 now. -5, -1.5, and -3. So here, let's see the final matrix, how it will be. It will be like this. -4 minus
5, which is equal to -9.
-5. This is the first one. The second one, 0 minus -1. Then 3 minus
0.5.
0.5. Then 7
Minus
minus -3. So then after I make these steps here, after I have each corresponding elements, I want now to simplify the matrix. Yeah. -4 plus 5, 1. 0 plus
-1.
1.
And 1.
Minus 0.5, 2.5. And 7 plus 3,
4.
10. That it is 7 minus 3, and 7 plus 3. So 10. So this will be the final matrix. Is it clear?
Yes, miss.
Yes, miss.
Now the first period, now it will be, the first virtual classroom will end now. We'll take 1 minute and then rejoin